Hi, my name's Nick DeHaan, and I'm with the University of Michigan iGEM team. Here with me is Anna Lesneski and Ian. What's your last name, Ian?
Faulkner.
Faulkner, that's it. So, today we presented on a bioremediation project, and what this is it's a microbe that will eat a contaminant in the soil. It'll digest it and turn it into non-harmful products, and then it'll release these products into the environment. However, there are some hazards to this approach of bioremediation, mainly the fact that we've got new bugs that have been untested in the environment, and we're just releasing them with no constraints upon where they can go and what they can do. So in order to counter this, we designed a suicide mechanism, whereas after they have cleaned up the contamination, they will commit suicide and leave the environment as pristine as it was before the contamination.
Cool. So how does bioremediation in general differ from traditional remediation techniques?
Well, right now there is a traditional bioremediation technique where they use natural organisms, and oftentimes that's kind of destructive because they have to change this environment in the site in order to kind of facilitate the natural degradation of the natural bacteria. And some of the advantages of using synthetic bioremediation are that we can design totally new pathways so that we can degrade contaminants that were undegradable by natural bacteria. Also, we can tune it so that we can determine how much of the contaminant is left over after our bacteria are out of the system, and also we can make it extremely more efficient by removing metabolisms that are not necessary to the cell.
Cool.
Also, I think a really general difference between bioremediation and other forms of remediation is that bioremediation generally involves an ecological perturbation of the environment, whereas other forms of remediation are usually more of a physical perturbation of the environment, such as removing sections of say soil or whatever pertaining to our project and actually doing that outside of the environment, and that leaves
so much more labor intensive and expensive.
It is labor intensive, and it does affect the environment as well.
Yeah, bioremediation is good for like non-point sources. So if it's like spread out over a wide area, you have a way of getting at it in a cheap manner.
So what kinds of reactions do you guys get from friends and family and other people when you talk to them about some of the work that you've done with synthetic biology?
So I have a specific quote that I probably should open with. So I told my roommates about this, and one of them said to me, I believe this is verbatim, if you destroy the environment, I'm going to sick Al Gore on you. So with that, if anyone else wants to...
So obviously there's a little bit of fear that we are releasing new untested organisms in the environment. Oftentimes people are just amazed at the fact that we can change the genome of bacteria altogether, and the fact that this bacteria could be crawling all over them after they sit on their grass is kind of scary sometimes. However, when we counter with the fact that we are cleaning up contamination from other chemical processes, oftentimes they're a little more positive towards it.
Sure.
And especially when we explain their suicide mechanism and the fact that we're going to try to eliminate this bacteria, then they are generally won over and they're very supportive.
Have you given much thought to things like unintended consequences and biosafety in terms of not necessarily just your project, but synthetic biology in general?
Can we break this up into our project and then other projects?
Whatever you'd like.
So one thing that we have to consider in our project is the possibility of mutation in our kill switch mechanism, where if we have a mutation that knocks out one of our genes that kills the cells, then they will be able to run amok, so to speak. So what we're thinking of doing in a final device is engineering a set of redundant kill switches into the device so that if one of them mutates, then there's going to be 4 or 5 others that will still do the job through a different pathway, but it'll still achieve the same end of killing the cell. What else want to talk about? General implications?
Unintended, in general, of other projects. I'd say unintended consequences of recombinant DNA technology are not only probable, they're definitely going to happen. I would say it's not if, it's when, that type of thing, because the complexity of the systems that we're trying to model here are so vast that there's no way we can even come close with the current technology. So the question is not how can we eliminate the risk. I view that as probably impossible. It's how can we mitigate, how can we control it, and then how can we fix it after we've caused a problem. So I'd say that most people are starting to grasp the fact that this can be very dangerous, not only as unintended but also intentional consequences. And I think that there is a movement starting towards greater regulation and a greater also a public outreach to try to help people understand the positives and the negatives of this system.
And you think that public outreach is important?
Absolutely. I mean, if you don't have the public support, then you're not going to last very long. You need money. You need political acceptance. You need laws that allow you to do what you want to do, and you also need to be able to freely share your information, or you'll dry up from lack of new ideas.
Great. Thanks a lot, guys.
Yeah, thanks.
Thank you.